So London, Ontario could get like light to moderate rain. Peterborough, Ontario could get light to moderate rain. And most part of southern Ontario gets dry weather with some cloudy or sunny days depending on how it goes. Montreal gets nothing and North Bay gets nothing. North Bay gets nothing, I guess. And the freezing line is gonna be like 540. Like air temperature has to be 0 degrees. And elevation has to be at least close to 0. 200 millimeters. So just moving around the world, mostly around like Niagara Falls, moving thunderstorms for the whole day. Moving rain the whole day, just on a form of light to moderate rain. And then it gets cloudy and dark clouds possible at Niagara Falls. Toronto gets cloudy days, so then there's some rain disappearing in London, Ontario, and when it hits before it's Toronto, it disappears. Possible it could be thunderstorms near Windsor, Ontario. So Toronto could get some light rain. Ontario gets some light to moderate rain. Orange will get some light to moderate rain. So I'm gonna open the so total rainfall. Zoom in the term. 6 hours was it? So 8 a.m. So 24 more 24 hours. Let's get more. So tomorrow is going to be like 2 millimeters of rain near 0 in Scarborough, Ontario. It's like 1 millimeter of rain or half a millimeters of rain. And then next, like morning to evening, it's Sunday. So Toronto is like Toronto is gonna be like 8 millimeters of rain or 7 millimeters of rain. It shows up in Toronto Island. Scarborough could see 9 millimeters of rain. It's under 10 too. So Toronto could get some a millimeters of rain, 8 millimeters of rain in Stouffville, in Scarborough, Ontario. They could get some 41 millimeters of rain. Brampton could get some 4 millimeters of rain. 5 millimeters of rain in Ottawa, Ontario. 12 millimeters of rain here. Peterborough could get some 41 millimeters of rain, which is heaviest rainfall I could find on this map. It's 54 millimeters of rain, which is outside of Canada. Or it's actually here. The heaviest on this map is on near Belleville, north of Belleville. Toronto gets some 2 millimeters of rain or 1 millimeters. 5 millimeters of rain in Brampton, Ontario. Barrie, Ontario gets nothing or some of rain from yesterday's. From Wednesday, yeah, Wednesday. That's to Tuesday. And this is the end of the weather model. Weather model. It could be longer. We can see. The actual one is 360 hours. In temperature pattern, the Toronto is 17. Everywhere in Toronto is like 17 to 19 degrees. Or 15 degrees because of lake breeze. Seven a.m. tomorrow morning is like 7 degrees, lowest temperature of the day in Toronto, 67. And the warmest part of the day is 10 degrees, 12 degrees, 13 degrees around Toronto. 8 degrees is lake breeze. 7 degrees in Toronto downtown. 6 degrees, 6 and 5 degrees around Toronto. 10 degrees, 10 degrees, 12 degrees, 14 degrees around Toronto. London, Ontario gets 16 degrees, 18 degrees near 17 degrees in Barrie, Ontario. 9 to 11 degrees around Toronto. 10 degrees in London, Ontario. Barrie, Ontario gets. The highest in the map is like 14 degrees, and lowest temperature is 4.9 degrees or 5 degrees. 12 degrees plus lake breeze is 10 degrees. Around Toronto is like 10 to 16 degrees around Toronto. Peterborough gets 16 degrees. 15 degrees is 70. The coldest part. So 10 degrees in Toronto, 10 to 12 degrees around Toronto, and 12 degrees in Newmarket, and 12 degrees in Peterborough, Ontario, and Hanover gets 12 degrees. 20 to 11 degrees around Toronto. 11 degrees in Scarborough, 12 degrees in Brampton. Toronto gets some 10 to 11 degrees. 19 degrees in Brampton, Scarborough 18 degrees, 14 and 11 degrees in Toronto, including Island. 5 degrees, 5 to 6 degrees around Toronto. Above average temperatures. You have to zoom in the whole continent to see negative PNA, positive PNA. You need the whole map, whole continent in this weather model. Positive PNA, then it's going to turn positive the whole time. It's going to turn negative for a minute, and then it gets positive by the end of May 8th. And the humidities. The humidity is going to come. Like dew point. So it's going to be a lot of dry air everywhere. Everywhere on this map is like mostly dry air and some moist air. Moist air is near the Gulf. But because of the high pressure or just a dry climate, it's causing. So this year, this winter is going to be snowy than a little bit changed in temperature. So in this winter could be colder and snowier than normal because of warmer waters and less dust storms. It causes because the Coriolis force is forcing the moisture to go north, then Earth's rotation causes to move to the east and causes more snowstorm. That's why it's gonna be colder and snowier than normal. December is colder and snowier than normal. January is colder and snowier than normal. February is also gonna be same thing, colder and snowier than normal. So if greenhouse gases stop, it takes a long, long time to recover from go back to natural temperatures. It's natural temperature, probably around more than 100,000 years to recover from climate change. Good. If we stop and don't do anything but climate, don't do anything but the atmosphere. If we stop also, then it's gonna recover. Could be recover. We will recover. We will recover and go back to colder and colder until it hits natural temperatures. More than 100,000 years. Because of scientists all use ice cores to study like Earth's climate, past climate, and how it will happen, what will happen in the future. It also depends on continental drift. So we look at this summer, it's gonna be like warmer than normal, except yeah, it's warmer than normal summer could be, and wetter than normal, more rain than normal rainfall. Even this below average because of the rain. Below average temperature is caused by below average temperature caused by rain. That's why it shows up like below average here. And tornadoes also form with more and moist air from the Gulf and combines with cold, dry air and it creates tornadoes. Also, Canada gets some tornadoes, but it's going to get worse because of climate change. You won't notice every year. It just depends how long you live there. Like if you look at the history of Google. So we wait like so if, so if we like wait like 30 years, you could see like some effects of climate change. Mostly like 30 years it's gonna be shows up. Yeah, it's like 0.2. Like Toronto warms up like 0.2 to 0.4 degrees per decade. But in last 2 decades was 0.2. 2 decades was 0.2 degrees, but 1 decade was 0.4. But the climate is gonna keep changing even if we stop carbon emissions. It's gonna be changing forever if we don't pollute the atmosphere forever. It's gonna change forever. Change until the red giant in the sun. So this winter could be also negative AO. You need the whole northern hemisphere for it to show up. But this winter could be positive. Negative AO Arctic oscillations is negative AO for December 2025. January could be negative AO. and February is -8. If you see the like so much warmer than normal temperatures, it could be just like oscillation is causing it, or just global warming. Some of it is global warming shit. So. But if you notice the super warm temperature, that's normal weather pattern. Sometimes the global warming just shows up extra in the weather model. Sometimes it doesn't show up, it just shows average. So this is above average because of global warming is catching up some, or it just crashed. And in the weather models, is something just glitches and it's warmer than normal. Because global warming is we're just still warming up right now, slowly. Or mostly it's an oscillation. So this winter could be also positive PMA. Yes, it's gonna be mostly like positive PMA. If you look at it in Western US, it's gonna be like above average temperature. You can see negative PMA, warm in the east, cold in warm in the west, cold in the east. But El Nino and global warming, you can't tell if it's warmer or cooler than normal. Because global, or it could be just sometimes. It's actually the oscillation is causing all this warmer than normal. But it doesn't make any sense with climate. So pressure doesn't do any. Yeah, pressure looks like a La Nina pattern closely. This, but there's no. Well, it could be colder and randomly it's. Yeah, snowstorm is gonna be hard to. Hard. It's gonna be. Snowstorm is gonna be. You can't tell if it's gonna snow in this weather model because it's warmer than normal in the Gulf and higher pressure, higher than normal pressure in the North America, and lower pressure in the Arctic. So also continental climate is somewhere here, probably north. It's a little bit far north. There's also Gulf Stream weakening and AMOC weakening that causes colder winters, colder and snowier winters because of the Gulf Stream is weakening and AMOC is weakening. AMOC is weakening. That means if it weakens AMOC or Gulf Stream, it gets warmer waters, warmer breeze, warmer, and the earth and the colder air when the ice melts. It brings the cold air. Yeah, it brings the cold air from the Arctic all the way to the all everywhere in North America. Brings some more. So it's gonna be colder and snowy in winters in summer years. So sometimes it's warmer and wetter winters. Some years it's gonna be hot and wetter summers. And yeah, that's it. It's gonna be hot and wetter, hot and wetter, hotter and more rain. More hot and more rain in the summertime, colder and snowier in winters, and warmer and more rain, less snow. Less snow because of climate change, AMA collapse, and Gulf Stream collapse. But Gulf Stream and AMA collapse caused Gulf Stream weakening and AMA weakening is caused by climate change, warmer climate in the Arctic. And there's also it makes the cold water less, more fresh water, cold water to go south and makes the around the northern hemisphere colder. La Nina is not actual, not an actual climate change, not actual like La Nina doesn't. It's not climate. It is weather. But the Gulf Stream and AMAC is climate system caused by like in climate change melting the ice. If we close to the ocean, like Iceland, it's like a whole oceanic climate. But if you near land like Canada, it's gonna be human continental climate. Except yeah, Vancouver is moderated by the oceans and Gulf Stream. That's is the current. But somewhere in like Newfoundland is also moderated by a Gulf Stream. But this pressure, this like oscillation lasts for months. There's also pressure somewhere here, lasts for a month. Months. So how does La Nina bring to the so how does La Nina bring a colder and snowy than normal? Because somewhere in Antarctica, cold from somewhere in Antarctica releases cold air to the equator of Pacific Ocean, and the bird. So then the warm air just splashes. Then when it's pushed, the warm air in here it is pushed to this Australia, and forces that rage somewhere here and brings it in blocks the cold. When the moving cold it goes west to east, the cold is pushed and tilted a little and forces all the way to the eastern U.S. That's why it's running colder than normal here. And but La Nina also brings warmer than normal. When warmer is pushed, when when it's colder than normal here, it pushes the warmer than normal temperatures and it pushes here. Then a massive ridge just shows up. And there's a cold air in the Arctic. It is moved a little bit to the east, and then it crashes down to the Canada. Oh yes, Canada or US. But it's still colder than normal in the west. So, but it's going to be warmer than normal in the southern US. But it also makes makes the high pressure system stronger on this line. That's like warmer and drier than normal. But the hurricane season, so La Nina, makes it worse. Makes warmer than normal temperatures. and it makes the precipitation like unpredictable. That's why you get droughts and floods in Florida. Like say it could be like same time it could be droughts and some there is floods, jumps to floods. That's La Nina brings, including El Nino brings less hurricane because of more dust. Sometimes below average temperatures, also below average temperatures. Sunday doesn't show up, but in El Nino brings more dust storms and blocks all the rain in entering Florida or the Gulf. But El Nino brings warmer and wetter than normal in southern Ontario. So that's why like some winters just go like warmer and drier because of extra force, because of a negative PNA. Extra force pushes to the negative PNA, positive PNA, it being cold and snowing. Sunday there's too much warm air just pushed too far in the north, and La Nina makes like drier and warmer than normal and drier than normal, but the ocean is gonna be warmer than normal because of La Nina, and drier than normal is Florida, but the warmer gets pushed too far, it then makes warmer than normal, but the hurricanes in the oceans are too warm, and it brings warmer, wetter than normal pattern. This is not La Nina is not the only one. It is also other oscillations like mostly like PNE, PDO, and AO is also another causes weather. La Nina just change the whole pattern, weather pattern a lot.